So today we're going to solve number 47, permutations 2. So yesterday we solved the permutation, and we add another constraint here, which is that the input array might have duplicates. So for instance, this 1, 1, 2 now only have 3 output instead of the previous exponential answer. So it's very similar to the combination and combination 2. Before we're just going to find a way to the previous solution that constrain some answer without being duplicated. So I think a good way to do this is that, so previously we have left and right and index between left and right, and we swap left with the index. So let's say if 2 is the index or 2 is the left, 1, 2, 2. So before we're going to swap left with so for instance, this is left and this is our index. Previously we're going to swap every index with left, so we're going to swap 1 with 1, and we're also going to swap this one with this one. So this is the place where we can check if the index is equal to the left. We don't want to swap, because after swapping we're going to get the same result. So that's the only constraint that we're going to add. So similarly, still the backtracking method. And passing nums, answer left and right. And initially left is 0, right is nums dot length -1, returns. So we have nums answer left and base case is left equals right. We add the current answer to the output array. Left is greater than right. Return if left is less than right. We do the recursive cases where we firstly do swap I was left, recursion is left plus 1 right, and swap back, and then we're going to do our swap method. So this is the place where we want to add a constraint. So if I is equal to left, we don't want to swap. And since this is in recursion, and we need to find a good way to do this. And to check for duplicates, hash set is always the way. So we can do this. So this means that we have a hash set in each of the recursion, and if we have already had a num I, which means our num I, so in this case, so for instance, we do the swap. For instance, this is left. We only do the swap if we only have one. We don't have the duplicates. For instance, we swap 1 with 1, and we don't swap this one with this again. And we swap 2, and we don't swap this one with this one again, because it will always produce the same result. If we swap, for instance, we swap 2 with this one, we don't want to swap this 2 with this one again. So this is a very clever way to do it. Let's see. This should be num start length word, right, +1, because usually we got this. Alrighty.